So in this second part, we'll go into the European norm, the EN 17522, the design and construction of backfilled and grouted borehole heat exchangers. This norm was developed in 2023, and it's partly based on the International Energy Agency Energy Conservation through Energy Storage Annex 27, the quality management in design, construction and operation of borehole systems, which was, the final report was done in 2020, and it was put together by a very international group of specialists from Europe, the United States, Japan, and other parts of the world. There is a parallel norm for open loop system water wells, which is still under construction, but the closed loop part is finished in 2023. It was done by the European Committee for Standardization, and the French AFNOR Normalization Institute was actually the main author of this norm, the organizer of this norm. So a few general aspects of the norm. First of all, if there is a European norm, it has to be translated into national norms. And if you check out this norm on the internet, you will find that it has already been published as a number of national norms. However, it does not mean that it also needs to be implemented in law. If you have existing or better norms and certification schemes, you are not required to implement this norm in law. And the norm is indeed partly normative, but for a large part also informative. The idea was that a lot of countries want to develop ground source energy systems, but do not have a norm in place. And this will then be very helpful in, designing the norm and certification system in that case. Like I said, the parallel norm for open loop systems is still under construction. And that will be for water wells that are used for geothermal energy, but also drinking water wells are covered in that norm. Now, the norm will treat several geological and environmental aspects, including risks. Think about karst geology, think about artesian water, where you have a high water pressure underground. So if you drill into that water, you will get a fountain above ground, which is not something that you would like to have. It also includes a system description, and it deals with different types of borehole heat exchangers. A little example here, where on the left you can see a single U-tube, in the middle a double U-tube, and on the right a concentric heat exchanger with the different construction parameters lined out below. It also goes into the different materials, the pipe materials for the vertical part, the connection materials and connection methodology, heat transfer fluids and backfilling materials. In the little table on the right, you can see different characteristics of a typical U-pipe loop with PE polyethylene 100 as a base material. Quite important, of course, to have the correct quality of the material, especially in the vertical part that is installed to great depth and cannot be, repaired or changed if something should happen with that. Another important part of the norm is the whole design process. Both the general design process, so the whole design loop from gathering information to checking your final design and iterating back into the first step of the design to arrive at the end at an optimized design, including a sensitivity analysis of different parameters, how they may affect your design, so that you know which parameter has to be, let's say, assessed with more detail than other parameters. This is always complicated because in fact, which parameter is important also depends, for instance, on things like energy balance and the ratio between the capacity, the heat capacity, the thermal capacity, and the total energy that is being extracted. Thermal properties of the ground are, of course, important. The thermal conductivity, heat capacity, and temperature profile. We even go into thermal response test methodology, so how to test the thermal properties of the ground on site, and the calculation and modeling procedure for calculating the temperature effect of a specific system and calculating the size of a system to achieve a certain temperature, and with that temperature, a certain efficiency. The norm goes into the construction part as well, the site preparation, the drilling, the borehole loop installation procedure, backfilling and grouting. So filling the borehole and making sure that it seals the different sealing layers in the ground properly, how to do horizontal connections, and how to test the system for leakage and for strength before it is put into operation. The operation part then covers the startup period, where, for instance, you can also take into account that a new build will need to be dried, which requires a higher capacity than a normal operation. So take that into account during startup, monitoring of the system, and maintenance. With maintenance, especially, we look at the quality of the heat transfer fluid, the concentration, the freeze protection, and, for instance, the bacteriological quality, which may affect it in long term. So we want to keep an eye on that. For large systems, you can do this, for instance, once a year. For single family houses, usually we propose to do it in a, let's say, sample way. So if you have 50 houses, maybe you check 5 of them every year. Filters, cleanliness of filters is important, because a clogged filter will lead to higher pressure drop, lower flow rate, and may even cause technical issues with running the heat pump. And the static pressure in the system is an indication of potential leakage, but of course also for the pump, we need a specific pre-pressure for the pump, so the static pressure should be maintained at all times. And finally, if after 30, 40 or 50 years of operation, you don't want to use the system anymore, there is also a part dealing with decommissioning of the system, how to put the system out of operation and leave it in a way that it is not affecting the environment in the long run.